Welcome to our Fluke Biomedical Demo Day, and today we're going to be covering the QA-ES III Electrosurgery Analyzer. We have a special guest today, Justin Ross from Roscoe Solutions. He will be here to address any questions you might have about this device. We've prepared a short video for you, but before we play that video, we'd like to take a quick poll from our audience, and we'll go ahead and do that right now. All right, I'm launching the poll here. So how are you connecting your ESU to the test device? So here are the three different answers. And if I could have you guys go ahead and submit your answer, and we'll talk to it in a moment. We'll go ahead and close the poll and share it with everyone. All right, so good. 0% use the ESU pencil directly to test. 19% connect the alligator clip to the ES2 pencil, and 81% use test leads. So Justin, you wanna talk to that a little bit?
I think some people were studying up before this presentation, Dan. That's awesome. You know, we don't ever want to go straight to the test port of the ESU. That's a good way to damage the ESU or analyzer, or damage your ESU. Also, it's a good way to maybe cause some harm to your fingertips. An alligator clip to the pencil, you know, there are some times where it's absolutely positively necessary to do that, but if at all costs we want to avoid that, we always want to use test leads to make nice secure connections straight from our analyzer to the device we're testing. And again, like I said, I know there are some very rare cases out there we don't have another option, but when at all possible, try to use your test leads. And a great thing about the QA-ES III is the fact that it comes with so many cables and they're so universal that you really don't ever have to make improvised connections. You should be able to do a direct connection straight from our analyzer to the device you're testing. So that's great, man. That's some great data, Dan.
Great. Well, let's go ahead and play this video we have for you, and then we'll have a little bit more presentation and get to Q&A.
We're here with the Value Lab Davidian FT10 and the Fluke Biomedical QA-ES III. And what we're going to do is we're going to go over some quick connects. If you're out in the field and you want to do some quick energy output testing and you might not have all the accessories for the FT10, maybe you're missing some foot pedals and things, how can you go about hooking this unit up? So this is where you show the true potential of the value of the Fluke Biomedical QA-ES III. So the first wire I want to show you is right here. This is our CQM adapter cable. It's for a dual pad configuration for your REM or arm testing. And what we have the capability of doing is the FT10 is so smart it won't recognize single foil pad connectors. We do have a single foil pad. Here, I'll show it to you real quick. Here it is. And if you notice, if you connect it in, it sets off the REM alarm. It's not going to accept that. So we need to put a dual pad in. So we'll just disconnect that and we're going to put in the dual. Here it is. It's got the DIN pin on it and it's got the two connect wires on the end of it. We're going to connect that into here. And in order to satisfy the requirements of the FT10, we've developed a man in the can. This is a resistor, so we're simply going to plug it in line with our dual cord REM pad like such. There you go. And you can now see that the green REM light is on. That has satisfied the REM requirements of the FT10. So now we have two wires. The only thing we need to do is connect one of these. Either one's fine, but just because it's staying color coordinated, I used a black connector and plug it into the variable low of the QA-ES III. So what we'll do here is we're going to do a simple monopolar 2 output test. So we'll grab our red cable, our red variable high cable, connect this into the variable high of the QA-ES III, and we're going to put into the single port on the left of the FT10. There we go. And since we don't have a foot pedal, there's no way to activate this. We're going to simulate a foot pedal using the yellow and the blue cables from the QA-ES III. So this top quadrant right here, this section, this is to simulate the foot switches of the ESU. So we'll simply connect the yellow cable to the yellow, and the blue cable to the blue. Then on the FT10, they're inverted. So where here the yellow's on the left, blue's on the right, we're going to put the blue on the left and the yellow on the right. Once this is completed, we have satisfied requirements of the FT10 saying that we've connected a handpiece and the lights are on. So now we need to have an activation cable. So you notice up here on the QA-ES III, there's one port missing, this common port. So we'll take the short black cable, we're going to connect it from the common of the QA-ES III to the back side of the variable high port. There we go. So it's from the common port down to the back of the right cable on the QA-ES III. Now we're just going to pick some outputs here. We'll go ahead and we'll run this up to max settings. So 300 ohms cut and 120 coag. Now we're going to go to general output test on the QA-ES III. We're going to select cut and we're going to put it at 300 ohms. There we go. Okay, now once that's done, on our foot switch F2, above F2, where it says foot switch, you see the arrow, we're going to toggle up to cut, and we're going to push start single. Start and single will activate the cut. Here's your results. We had 300 watts, we now have 288 watts, and we can see these results, right? The results are saved as test 2. So there's how we test cut. Coag is just as simple. We'll push the F2 button, take it down to coag, and we're going to push start single again. Coag is activated. 120 watts, we were at 113. This is just a quick function test to get the actual readings. You should open up your service manual and read what your settings should be and what ohms resistances you should have, or loads we should have, and what milliamp outputs. But typically, I guess, coag is done at 500 ohms, so we can turn up to 500 and try again here. Start single. 120, there we go, 115. So we're pretty close there, within 15% or so. And that's how you're going to do monopolar. So we're going to disconnect these cables here, and let's go ahead and let's talk about the bipolar output. Just to make it easier, we're going to get rid of all of these cables. So I'm just going to set them here on the floor. Now the problem is, here we go, take all these out. Now, for bipolar, we're going to use our right cable. We're going to go to the variable high and the left port of the bipolar. And we'll take our black cable and we'll go from variable low to the right port. There we go, now our bipolar is activated, but we don't have the pedal here, so we can't activate this. So if we get back into the accessory kit, the QA-ES III, you'll find this cable right here. See, the end of it's a little bit different than the other cables. It's missing the banana pin. This we're going to put from the cut of the QA-ES III down here, and in between these two ports there's a small little hole, and that will plug into there, right like that. Now we need a common jumper here, so we're going to run this common jumper from the slit section to the back of the red port again, just like we did the monopolar. And since we're plugged into cut, we're going to select cut with the foot switch. We're going to take this down to 100 ohms. Again, refer to your service manual to find out where you want that. Here we have 70 watts. Start single. 70 watts is activated. And here we have 67.7 watts. So there again, we have tested the monopolar output and the bipolar output of this ESU without using the foot pedals. Again, a nice, quick, easy way to go out. You get a call up in the OR and they want you to check it out real quick. Nice, quick, easy way to hook it up without having to find all your foot pedals. Well, that leaves the ligature. So the ligature, unfortunately, you're going to have to remember how to get in the service manual, but we'll show you how to do this here real quick while we're here. Disconnect all these cables. The ligature cables look a little different again. We're gonna hold up a black, here's your standard black variable low cable, and here's your ligature cable. See how the ends are different? This one you can butt them into. With the ligature, there's no port in the back. So we're going to take the variable low over here to the far right port of the ligature, and we'll take the red ligature cable to the variable high, and over here to the left port of the ligature. There we go. All right, well now I see the REM pad's not satisfied. So what we're gonna do is we're gonna go into service mode. And then we're gonna go into service, and we're gonna enter the access code. You can find that in the service manual. 423213. Again, please reference your service manual to make sure everything's safe and you're within the specifications. We're gonna hit OK. We're going to go to RF output tests. Once we're here, we're gonna select BPR coag, effect 6, put 50 ohms here, start continuous on the QA-ES III, and activate. And there you can see you have 1,832 milliamps, and over here you have 1,866.6 milliamps. There you go, that's how to test the ligature real quick.
Great. I love that video. Thank you for sharing that with us, Justin. We're going to show you where you could find that video, and along with some others to help you with testing ESUs. Before we get into the Q&A, I do want to do one more poll question, and I am going to go ahead and launch this poll and get some feedback from our audience.
This is another good question. We'll see how many people did their homework on this one, Dan.
All right. So how many devices are you currently using when testing an ESU? So 2 or less, more than 3, or you're not testing. All right, we're going to go ahead and close the poll and share the results.
2 or less. Okay, so we got some people not testing yet. Maybe we can show them some pretty cool stuff here. Now they saw that video, let's see how easy this is to do, and maybe they'll start testing some ESUs. More than 3, only 8%. 2 or 3, 60. Okay, that's some good data, man. So here's something to think about as we move forward. Dan, you want to roll that next slide for us?
Yes, let me go ahead and hide the poll. And great, Justin, if you want to share these online resources, I'll let you take it away.
Yeah, so we're going to impact that poll data here in a second, but on this slide, we want to show you where to get some more of this training. So what we showed you today was some quick, easy ways to hook up that QA-ES III. Now here's the problem. In 3 months, 6 months, a year from now, you maybe get your QA-ES III ordered in, you get it in, and it's time for the next PM cycle, and you don't remember how to set it up. Here's some great resources to get some training. The Advantage training, go to the Fluke Biomedical website, over to the far right to the Knowledge Center, scroll down to Advantage training. It's free. You can find training for all of our products there. Once you get logged in, it takes us a little bit to send you back your credentials. If you don't see them in your inbox, please check your spam filter. It might got eaten by your spam filter. Log in, find that QA-ES III. You can reference back to that at any time. Don't forget, it's part of our Empower series, so it does count for 1 CEU, 1 ACI CEU there. And the other place you can go to is our applications page, www.flukebiomedical.com/application/electrical surgery. And there we are. And here's the landing page, and you can get in here and see that exact video that we just covered, or scroll down and see how to do some of the specific tests with the FT10 and the QA-ES III. So now the question is, what if you don't have an FT10? What if you have the old Force Triad or Force FX? Where do I go to find information on that? Well, we also have the entire Force Triad video. So you can go back up to the Knowledge Center there. Here we go, and down to videos. And you can find all kinds of how-to videos, not just for the QA-ES III, but for all kinds of our products. You can also go to, here we go, yep, scroll down, and Electrosurgical Analyzers. So here's some more videos of how to set them up and how to do. You can also go to our Fluke Biomedical YouTube channel and find even more videos of how to use your analyzers. So you have the Knowledge Center with free Advantage training. Please take that training. It's a great way to start. you have these demo videos. And then if we go back to that application page one more time, a little bit of a lag here with the computer. There we go. And we'll scroll back up here just a little bit, and let's, right there, it says ESU Connections Quick Guide. Check this out. We built this really awesome PowerPoint presentation. We'll go ahead and click on there. And here it is. Is this everything you need to know? No, but this is a good starting point. I can't emphasize enough. Please read your service manuals. You need to find out if there's any special connections, what loads you need to be using, what resistors those loads need to compile. All that information is there. But here essentially is a really quick guide. Monopolars, monopolars, monopolar. Bipolars, bipolars, bipolar. This will apply to many of the setups. So this there, you can always pull it back up anytime you need it and figure out how to connect your ESU. So now let's go back there one more time, Dan, and we talked about how many devices you might need to test your ESU. There we go. So everybody that said 2 or less, the 63% of you 2 or less. Now let's go back to that applications page one more time, Dan, and let's show them all the potential devices you might need for your ESU analyzer. Back to the application page, sir. There we go. And there we go. So some things you might want to consider. Not only do you need your ESU, your QA-ES III Electrosurgical Analyzer, you might also need your electrical safety analyzer. Remember, once we're done, we're going to do our output tests, our CQM tests, or contact quality monitor testing. We're going to do our bipolar, our ligature, high voltage testing, or high frequency leakage testing, our cross coupling testing. All that can be done with the ESU analyzer, but then we need to do our rest of our electrical safety tests. So you need an ESA. How about this? Anybody have an argon beam coagulator? When's the last time you made sure that the argon was flowing at the correct rate? So you might need a gas flow analyzer for this. So the VT650 is a great option for checking out those argon beam coagulators. And way down here on the right, how about this 190M scope meter? You know, if you find something wrong with your QA or with your ESU, you might need to get in and see what that waveform is. What is the energy output? A nice feature about the QA-ES III is on the back of it, we actually have a port that can connect straight to your 190M scope meter, and you can see that output waveform of the ESU that you're analyzing. And believe it or not, that's actually listed in some of the service manuals. So again, if you haven't opened up your ESU service manual in a while, maybe thumb through it real quick and make sure there's not a test that you're missing, and you didn't even know that you could do it because of all these great products. But I'm done.
Great. Thank you, Justin.
So
well,
I guess the
I want to remind everyone.
Could have up to 4.
Exactly. Well, I want to remind everyone to send your questions in. We've had a little bit of a quiet group here today. A couple questions have rolled in, but I want to remind you to use that questions feature in the chat, and let's move on to Q&A and get any questions you might have about testing ESUs and about the QA-ES III. So let's see.
Oh, we should also point out, Dan, that in the handout section, we have that quick connect guide we just showed you. So if you go to the handout section of this webinar, you can download that quick connect guide right now.
Yes, exactly. Well, we have one question here, Justin. It says, do I need extra accessories when I purchase the QA-ES III?
That is a great question. And generally speaking, no. You'll find that the QA-ES III comes with just about everything you're going to need to do your testing with. The cables that it comes with are secure. They're safe. They have the spring-loaded safety tips, so if a cable falls out, you can't accidentally disperse energy. But you'll find that just about everything you need is going to be in there. I say just about anything because there are some very specialized ESUs out there that take a special test lead to connect into the ESU to allow the ESU to operate and to be tested. But for the most part, everything you need to find is in that QAES III accessory kit, which leads me to this. Also, after lots of asking from all of you guys out there, we can now offer you a complete accessory kit. So if you're in that biomed shop or your cables have a tendency to get up and walk away, or your REM bypass cable, maybe malfunctioned, you can always purchase an entire additional kit. So that's also available. Don't hesitate, give your local rep a call and they'll hook you up with the part number.
Great, thank you, Justin. All right, we're starting to get a couple questions, some more questions here. All right, here's another one. What is the importance of looping from the COM to the high variable port in the QAES III?
That's a great question. So if you think about the pencil that you use when with the ESU, a lot of the pencils for monopolar have two buttons. You have a yellow button for cut and a blue button for coag. And if you notice on the other side of that lead, so you have your pencil, on the other side of that wire, you have three banana pins that connect into the ESU. One is the energy output, one is the cut trigger, and one is the coag trigger. And the way it works is when you push that blue button or yellow button, it jumpers from the one pin to the energy output pin, and that's what activates the ESU. So on the QAES III, in order to simulate that, we need to have that cable go from the common to the backside of the variable high or the red port. So that way, when you push the cut button to activate, it'll go ahead and activate the cut, and it draws that signal to come through into the pencil, simulate, or if you push coag, it lets you come out of the coag port and to the variable high. So that's what you're going to use to actually activate your QAES III and your ESU.
Great, thank you, Justin. Now we're getting some more questions coming in here. All right, the next one is how much frequency current using cut and coagulation current mode?
Are they asking? I'm not quite sure I know exactly what the customer's asking there or what we're asking. Are you asking what the frequency response range is for the QAES III?
Now let's see if we could get some more answers from them, and we'll come back to that one.
Yeah, that's another great one. If you have some specific questions about that frequency range, check out the operator's manual. So if we go back to the Fluke Biomedical website and we go to the products tab and scroll down to the ESU analyzer, go to the QAES III and go to the specs. You can get all those specs about the frequency responses and their ranges, like the CQM that goes from 0 to 475 ohms by single ohm increments. All that data can be found right there in that specs tab. It's a great resource, as well as a copy of the operator's manual.
Great, thank you, Justin.
Oh, there's one, Dan. I like this one. Need cable picture with detailed description will be more convenient with the connection diagram. So, I agree, and that's why we made that quick connect guide. So if you look at that quick connect guide, not only do we try to show you a picture of where the wires go, you'll see that there's different ESUs in there. There's a FT10, there's a Force Triad, there's a Force FX, there's different ESUs in there, but what it highlights is the common similarities between them. Like I said, monopolars, monopolars, monopolar. So not only can you see the picture where the cables go, but we color coded it so it says red cable and red writing, yellow cable and yellow writing, really to help you lay it out. But again, reference that service manual because there might be some special cases out there. And a lot of these service manuals do a really great job of depicting exactly where those cables need to go.
Perfect, thank you, Justin. All right, we have another one here. What are the most common mistakes while doing electrosurgery?
While doing electrosurgery,
I don't know if that's testing or
testing, some common mistakes are not using the right loads, right? So, for years we tested, we assumed we were going to use 300 ohms for cut, 500 ohms for coag, 100 ohms for bipolar. And that's kind of was handed down from generation to generation of biomeds. But what you need to find is open up that service menu. You might be amazed that you're using the wrong load output. You know, a few years ago, we were measuring watts, right? Now, a lot of the service menus are calling for milliamp outputs. So you need to make sure that you're testing the right parameters. Connections, again, it can be overwhelming, but simply follow a quick connect guide, look at your service manual. But some people make some mistakes in setting up the outputs. If you make that mistake, you'll get some weird readings. So again, if you're looking at the service manual and your outputs aren't in the ranges, that's a good indicator that you might have done something wrong. Go back and relook at that step and make sure that you have all your setups correct. If you're still stumped, don't hesitate to call in to our tech support team. They're a great team. Email them, they'll get back to you and help walk you right through your setup issues.
All right, we probably have time for one more here. The connection, here's one. The connection in high frequency leakage test in bipolar is very complex. A lot of cable connections. Is there a way of making it simpler?
Unfortunately, no. But if you break it down to the simple steps, you're using a lot of these cables out already. So again, go back to that quick reference guide, check it out. It's color coded. You know, when I first started running the QA-ES III, we made that guide, I printed it out, and I actually carried it with me. I know I'm not a big paper guy, but here's something else I'm going to say. This is a great use for test automation or workflow automation. Fluke has workflow automation programs that you can use the QA-ES III with. You can save that test and that picture right into that step. So if you build a workflow automation on your PC and it ties into your CMMS package, when it's time to do the testing, you don't have to remember what to do because you logged it the last time. Take a picture, save that into the work order. Here it is time to do it again a year later. Oh yeah, here's the picture of how I did it. Connection, and you're done. Take a lot of that burden off yourself and put that into your workflow automation. Not only can you put those pictures in it, but it's going to save the exact data for you. So you're no longer you're writing stuff down on a scratch notebook piece of paper and then beating feedback to the biomed shop to try to type it in. Why not just log all that data straight into your work order so you don't have to worry about it? Was it a 7 or a 4? You know, by my penmanship, I should have been a doctor. Computers were built for me, just like workflow automation. Try to make it as simple as you on yourself as you can.
Thank you, Justin. Well, we have one more here. I think we could squeeze one more in.
Go for it, man.
And it's talking about, you know, other ESU devices. It's the REM connection is the REM connection common for all ESU devices, or do we need to change by manufacturer?
That's a great question. That's a great question. There's always an exception to the rule, and for every rule, there's an exception. So that said, what we showed in the video, we're actually calling CQM, or Contact Quality Monitoring. That is the proper ISO term for it. REM's pretty specific to Valley Lab Covidien. You might also hear the term ARM, ARM. These are all different phrases for contact quality monitoring testing. So yes, there are different connections. Do you actually have a dual foil pad, which is sensing the resistance from one pad to the other side? You know, something used to happen in surgeries, that pad would start to peel off and you start to get patient burns. So now we have these dual pads. They're going to measure the resistance between the two pads to make sure it is safe for the patient. So making sure that you have that dual pad, or is it an older issue and is using a single foil pad? Or are you using a high frequency issue and it's not really using a pad, it's using an antenna or a patient plate? So those are some things to consider. Now, how it connects back to the QA-ES III, that's pretty universal. But as it goes to the ESU, you're going to really need to reference your service manual because there can be some variations of it and some slight differences in the testing.
Great, thank you, Justin. Well, we do have one more question here, and I think we could squeeze one more in, and then I know everyone has busy days, and I want to get you guys back to your jobs here. Does twisting the cables whenever connecting the QA-ES III to the ESU affect your test results?
Oh, yeah, that's a great question. Yes, it does. Or yes, it can. So you'll notice that all the lengths of the cable that come with the QAES III are a certain length. And there's a reason for that. Because we're running in high frequency energy, right? It's darn near RF energy. So right below that radio frequencies. So what you're doing is you're projecting energy out of one cable, and if your cables are crossed, you can get inductance and transfer the energy from one to the other cable. So yes, you always want to keep your cables separated if possible. Another great point on that, you never want to set the ESU on top of your ESU analyzer, or your, in this case, the QAES III. Again, you can transfer that radio frequency energy from one device to the other device. Also, you might find when you're doing your leakage testing, you don't want to set the two devices on a stainless steel back table. Stainless steel back tables are conductive, and you can conduct the energy through that table. So yeah, try to keep your cables separated. Try to use the cables that come with the QAES III because they're cut to a specific length and shielded to help reduce that cross coupling of energies between the cables. That was a good one, man. I like that question. Give that guy a gold star or girl.
Will do. Well, great, Justin. If we did not get to your questions, please send us an email, and we will definitely reach out to you and get your questions answered. But again, thank you, Justin, for your time. Thank you, everyone, for joining us today, and have a great remainder of your day.
Awesome. Thanks for inviting us.